Okay, so my name is Martin Möllhoff, and I work as Director of Seismic Networks here in the geophysics section. So the Dublin Institute for Advanced Studies, just very shortly, is a government-funded research institute, so we are not a university. And the institute was founded in 1940 by Eamon de Valera. He reckoned at the time it would be a good idea to have a research institute for the new state of Ireland. And as you might know, he was actually a scientist himself. He was a maths teacher. He was really interested into science. So this explains as well his idea to launch the DIAS, Dublin Institute for Advanced Studies. We have 4 sections: geophysics, right here, theoretical physics, Celtic studies, and astrophysics. So here we are in geophysics. Geophysics, of course, is the study of our Earth, of the globe, using physical methods. And one of the main areas we're working in is seismology. And seismology basically is the study of seismic waves that mainly come from earthquakes. So here in DIAS, we operate the Irish National Seismic Network. So we have a couple of stations around Ireland that send the data in real time. We record it, and then we have a system that looks for earthquakes, and we manually look as well. And that's what seismic networks do all over the planet in different countries. And you look at the local earthquakes, but also at the global earthquakes. So if there's a large earthquake at the other side of the planet, our station will pick that up as well. And all the different national networks, they share their data, and we are part of this global community. But it turns out that the seismometers that actually record these ground movements that come about from the seismic waves traveling through the ground, there are many, many other things actually shaking the ground. For example, we do a lot of work on volcanoes, not in Ireland, of course, on active volcanoes in Iceland and in other places. And these signals coming from the volcanoes, they're quite different to earthquakes. So they're more vibrations that last very long, and then they change slowly. Another example, more here in Ireland, is we study seismic waves that originate actually from the ocean. So the ocean waves, so the water is moving the whole time, obviously. Under certain conditions, a lot of the energy of ocean waves actually goes into the sea floor, into the seabed, and really transfers a lot of energy and makes the sea floor go up and down with the same frequency like the ocean waves. And that creates seismic waves that then travel everywhere. So wherever you put down a seismometer on this globe, you will see this. It's so strong. It's particularly strong, of course, in Ireland because we're so close to the Atlantic. And the study of this energy and those waves is a whole new part of seismology, came about the last 10, 15 years. So these kind of studies to not look at earthquakes, but at other things that make ground vibrations is often called environmental seismology. And something I'm also really interested in, and we have a lot of research projects going into that domain. And one of the things we recently found are these fin whale calls. So when you look at these environmentally caused seismic waves, you have to look in a different way than you look for earthquakes. You look at different frequencies of the vibrations, for example. So the fin whale calls that we recorded, surprisingly, we found this out last year in some of our stations. I just think I start by just playing you what they sound like. So basically, the seismic vibration, the signal, we can just put that into audio software and then you can hear it. So these fin whale signals, they're basically just a 1 second long sound, and then between 10 and 15 seconds to the next one. And actually it's called INI, inter-node interval, can vary in different regions of the planet and different fin whale populations. As I learned, I'm a physicist, you know, this is all totally new to me. I had to read a lot about whale and whale communication. So of course we can also look at this in a graphical way. We actually do that more often than listening to things. And as you can see, I should point with the mouse because we're recording this. So you see the cursor here moving about. So on the bottom, in the bottom panel, you see on the x-axis, you see time. It's about half an hour. And there's a seismogram, and you see the vertical spikes. They're these 1 second long fin whale calls. And the shape of all this signals is quite typical for fin whales. So they often make these calls for like 10, 15 minutes. So from, say, there to there, they're called bouts. And then there are these shorter, these gaps in there of like 20, 30 seconds. That's when the fin whale comes up to the surface to breathe. So fin whales are mammals, so they have to breathe. I think they can dive up to 15 minutes, 20 minutes. So usually every like 5, 10 minutes, they come up, and they usually don't call, they don't make a sound when they're breathing. And then sometimes you get these a little bit longer gaps in the sounds of 2 or 3 minutes. And that's probably when they dive a little bit deeper to feed or do something else we don't really know, actually. So if you look at the upper panel, all this stuff here, that's what we call a spectrogram. So again, on the time axis, you have X, and then on the Y axis, you have the frequency. And you can see the frequency is around 20 hertz. And these vertical bars here, they're the individual calls. So the frequency of these calls is, in this case, between 18 and 22 hertz. So what does that mean? So 20 hertz means a vibration that goes 20 times in a second. And that's actually just the limit in sound in air of what we can hear. Actually, we can't hear 20 hertz. It starts at maybe 25, 30 hertz. So the fact that we can hear this now through the speaker is that I actually tweaked the data a little bit, and I increased the pitch by a factor of 3. So what we hear here is about 60 hertz. But I didn't change the speed with which we're playing back the sound. So what we often do actually in seismology, when we want to hear two things, which is not very often, you just speed it up by 10 or 100. So everything gets compressed and is faster, but also the frequency goes up. But here, I didn't do that. That's why it says speed up times 1 there. So I didn't change it. Then here on the top, you can see, I don't know whether hopefully this is big enough for you in the back there. This recording was made end of November 2013, so that's 11 years ago. So, and it's a station in Ireland. Here, that's the station name, and the IA there at the beginning stands for Island Array. So there was, for about 10 years, a network of temporary stations that didn't transmit the data in real time across Ireland. And this is one of the stations, so that's why it says IA. And this station was located near Baltimore in County Cork. So basically, that's 10 years ago. I discovered this end of last year. So no one knew these signals are inside there. So basically, this data was downstairs here on our server, and nobody knew there were whale songs inside. You know, we used the data for other things, and normally the seismogram here at the bottom is filtered between 18 and 23. That's not what you normally do to look for earthquakes. So you have to look at it in a different way. So I specifically looked for this and found it. Well, maybe in other seismological institutions, there presumably is similar data and not discovered yet. So it's quite a finding, really. We were very surprised. How did we get the idea to look for all this, and what does it mean, and is it of any use? So that's really what I want to talk about today. So how we got there is basically through these instruments called ocean bottom seismometers. So most seismometers, of course, are deployed on land, but sometimes we use these kind of instruments that you can sink in the sea, and they go down to the sea floor, and then they record there. And that's roughly a schema how it looks like. Basically, you have a recorder, you have batteries, and then here's a seismometer. It has actually 3 components very often. So you measure how the ground goes up and down, and then sideways, east, west, and then south, north normally. And this flag and radio antenna is when the instrument floats back up, that you can find it and then pick it up from your boat. And here you can see there's often, actually always, there's a hydrophone as well. So hydrophones are microphones that work underwater. And that's what you usually would use to study whale calls, of course, because they're in water. So why are seismologists using this? Well, actually, before I explain that, I just wanted to show you a deployment of one of these instruments. So in Dyers, we got a pool of these instruments. It's part of this IMAL project here. And there's one of the seismometers, and there are also pressure sensors. And they were deployed in 2018 as part of a project called seismometers. I now have to go down with the volume before I start that video. And I have to change the pointer. Here you go. So here you can see how one of these instruments was deployed. So basically, it just gets attached to a rope via a hook, and then once it's in the water, the hook gets released. And there's a weight on the OBS, and it will just sink to the ocean ground. In this case, offshore Ireland often was like 3,000 or 4,000 meters deep. So actually it would take, I don't know exactly, but it would take like half an hour for the instrument actually to go down to the seafloor. And then later you come back and you give it a signal to this transducer. I have to put back on my laser pointer here. So this is a transducer here. And when you give that a signal, the OBS comes back up. This is the seismometer, and the black thing here, that's the hydrophone. So why are seismologists going to all this length? I mean, these instruments are first very expensive, and then ship time, as you might imagine, is quite expensive as well. Well, the reason, of course, is 70% of our planet is covered by water. But if you look at the map below, it shows all the red markers. Sorry for the quality of the figure. They're earthquakes, mainly they're the large earthquakes that happened. I actually don't know. I just picked the figure, over the last 20 years, probably something like that, mainly along the big plate boundaries. And the blue symbols are seismometers. There are actually many, many more, but it just gives you an idea, like where we have seismometers. There's less dense coverage in Africa, for example, and so on. But those few blue triangles in the Pacific, for example, they're just on those few islands that we have there. There's nothing really where we have all the oceans. And this is kind of a problem, really, to study earthquakes and other things properly. And that's why OBS are designed and used by seismologists. Well, when these get deployed, very often whale calls and other things are actually recorded. And I want to give you one example of an OBS deployment that wasn't carried out by us, but by the University of Durham in 2015. And you see on the map to the right in near Panama at the Costa Rica Rift. It's a bit small, maybe, unfortunately, sorry. So this dashed white square here is where this group of OBS was deployed, 25 of them. And my colleague, Jean-Baptiste Tari, he used the data. The data was not, those instruments weren't deployed to look for whales. It was like to study the underground and the deep structure of the earth underneath, etc. But he got access to the data and looked for whale calls. And there were a lot of whale calls in this data set. And he then used the whale calls that are in the data to locate whales. So in this case, you can see 3 whales crossing that seismic array. So the triangles are the different OBSs. They're about, like, I think, 10 kilometers apart from one to the other. So the whole thing here is like 40 kilometers by 40 kilometers, maybe. And you can see the whales traversing through it. That's pretty neat. I think they weren't fin whales. They were Brutus whales, they're called, which we don't have here in the North Atlantic. So that's very good. The thing is that these OBSs, they're very difficult to deploy, and they're not permanently there. You bring them down for an experiment, you get them back up. So you can't really use this to long-term monitor whales. So back here to Ireland, and I did mention that we have our own OBS pool here. We have 18 instruments, which for the size of Ireland it's a very large pool, actually. Probably the 3rd or 4th largest pool in Europe. And these instruments were deployed in 2018 as part of the Seasize project. You can see here the location nearly up to Iceland and to the Mid-Atlantic Ridge. And in those data, there were whale calls. And then there was another deployment 2 years earlier before we bought our own instruments, and we got a loan from the Alfred Wegener Institute. And together with them, we deployed, I think, 10 stations. And I want to show you some data from the station called here ORC 07. And here it is. So that's one individual whale call here. So you see the spectrogram on top. Again, it's around 20 hertz. And here's a not the seismogram, it's a hydrogram then. So it's hydrophone data. This is from the hydrophone. And you can then see here some signals coming in later. And these are basically reflections that come about when you see in this graph, you know, the first big blob actually is the signal that arrives straight on, you know, when the sound travels in a straight line, more or less, from the whale directly to our instrument. Whereas when you follow the dashed line, you get a multiple reflecting between the sea floor and the surface of the ocean. And the signal arrives later and weaker. And actually, there's yet another multiple. So that's interesting. The graph on the right actually is from a paper in Nature or in Science, where someone analyzed OBS data, so the hydro data, but also the seismic data from the OBS, and showed in this graph what happens, how the sound going through the water then actually transfers into the ocean floor, into the solid earth, and then comes back up via different pathways into the seismic station. And that's actually exactly what you can observe for our station. So to the right top there, you see the vertical seismic data, and then here the two horizontals on the bottom. What I wanted to show you is that you see the smearing out, basically, and that's because some of these seismic waves that go through the ground, you know, they arrive later than the first part. But the interesting thing is, when you look just at the front, it actually is undisturbed. It looks the same like the data that comes through the water. And that's something important later on when we look at our data recorded on land. Talking about that, there is one study by Plurd in Canada, and that's the only study so far published that discovered and presented fin whale calls recorded on land seismometers. And our study now is the second one. So there you can see that the waves, they go through the water into the ocean floor. But then when you're near coast and the seismometer is close enough, you can see it. And that's actually what happened. So in this map, you can see, hopefully, if it's big enough. So here in the inlet, the black square shows you the outline of the large map. And the triangles are seismic stations where we found fin whale calls. So the red one is the one I showed you at the very beginning, and the one we listened to near Baltimore. Then near Gully Head here in County Cork as well, there were 3 stations deployed, again, kind of 10 years ago, where I found whale calls in. And then the pink one here in County Waterford, that's operating since a year. And I will come back to this later on. But why does this work? I mean, that an animal, you know, gives a sound in the water and then kilometers away. So actually here in Baltimore, the station is 3 kilometers inland. I mean, this is, totally not what anybody would expect, I believe. Still, that's what we see. So how can that work? Well, the reason is, there are 2 reasons, really. So the calls that these animals make are really low frequency for an animal. It's 20 hertz. So on this graph, you see all the baleen whales types on the right listed, and then what frequency range their calls are. Or here it says moans and whistles. And you can see that the deepest frequencies come from the blue and from the fin whale, the 2 on the top. And here in the red dashed box, you can see what we can detect with a normal seismometer. Seismometer actually sampling, we usually sample with 100 hertz. So you can only analyze signals up to 50 hertz. So all these, you know, you have no chance to see that in seismic data, really. For the gray Brutus whale and so on, they don't exist in the North Atlantic. But I marked there the minke whale, the humpback whale. We have them around Ireland. But they are outside that red box. So with standard data, you're not able to see them. The orange box shows what you can do if you tweak and let the seismometer sample at a higher rate. So maybe in the future, if you do this, maybe we might be able to pick up some of those. So frequency is one thing. It has to be low. Also, lower frequencies travel further. They're not so attenuated, so it's easier to pick them up. But the other factor is that these signals from blue and from fin whales are extremely loud. They're actually, you can see it on the right. So they're on the same loudness level of a jet engine. So you're standing 100 meters next to a taking off aircraft. That's the kind of level of sound you get. Basically, you're close, or you're at the pain limit for a human. And yeah, I just mentioned there. So the dB, the loudness in dB is different. There's a different scale in water than in air. So the animals are able to do all this because they're so big. So the blue whale, amazingly, it can be up to 30 meters long and weigh 200 tons. I mean, that's the same like 15. I looked it up, Dublin buses, which is just amazing. The fin whale is actually quite a bit smaller. I mean, it's still 23 meters long, or up to 23 meters long, and 80 tons. That's still quite big. But actually, the energy in their calls is quite similar between the two. So how did we check what stations we might see these signals? So I checked with the Irish Whale and Dolphin Group, an amazing organization, it turns out, and they have this sighting scheme. So when you go to the webpage, that's the address, by the way, iwdg.ie, you can, if you see a whale or a dolphin, you can go there and report it. You click report sighting, and you can submit that. And many people do, all sorts of people, normal citizens, scientists, people on boats, or just you're on the coast somewhere and you see an animal, or people go intentionally in good weather and go and see what they can find. And I found this on their webpage there, even shipwrecked, Kevin is really dedicated here in his life raft. And he said, oh, no, see, there's a dolphin, I have to submit this through the app. So they also have an app. And but actually, they do this since more than 20 years, and it's an amazing database now. I mean, there's so many sightings in there. And what I also discovered is that there are now more and more people, when they go out and hear, oh, someone says, well, there are whales there off County Cork, off that and that headland or something. People go and have a look. Of course, I mean, that's great. And with social media, actually, more and more people are able to get that information. Then, oh, that's not so far. I just drive over and have a look. Well, and some people have a drone, and then they just send out their drone. So if you see a whale breathing out from the distance, not so easy to know what kind of whale it was. I mean, for an expert, maybe, but even at a greater distance, probably not. How many animals are there? Is there a calf? What is going on? There's a drone, you send it over. You see a drone images there on the right of a fin whale sighting. It was August last year in West Cork. And I have to check my sound level now that it's not too. And again, my pointer to start is actually video. And yeah, I found this on Instagram. So it has kind of TikTok-y, Instagram-y kind of music. So, but I left that on because you can also hear the whale breathing. Yeah, I think it nicely shows you how large these animals really are. And they're actually one of the fastest, if not the fastest whale. They can swim up to 40 kilometers per hour, which is the speed of I looked it up because I didn't really know, like a ferry or a big boat. They're pretty fast. Okay, so we got access to the sighting database. I plotted it up. First of all, for dolphins, just to, let's take it easy. And you see all the yellow dots are dolphin sightings in the database from the Irish Whale and Dolphin Group from 2005 to last year, all around the Irish coast. Well, there's probably a bit more going on than the Southwest, I would say. And you see offshore as well. So when people are out with their boats, especially on research trips, I guess. And then you can also see the where the ferries go. So often people see dolphins from the ferries. But of course, we are interested in blue and in fin whales. They have the kind of deep signal that we might be able to detect. Okay, so the blue whale, that's slightly disappointing. You might even not be able to see those few dots. Actually, in this graph, they're pretty small. But basically, if you can't see them, there are a couple of sightings. They're all fairly far offshore, where the water is a little bit deeper. You know, these animals don't really like shallow water, I learned, blue whales. And actually, on the map, the black triangles are seismic station of our national network. And then for fin whales, wow, okay. I plotted larger circles, fair enough, but still, I mean, they're actually really close to the coast. I mean, when I didn't know anything, actually, I didn't even know we have fin whales that close at all. I hardly know the difference between a blue and a fin whale a year ago. So plotting this, we're like, wow, that's really close. There might be really a chance, maybe. I mean, all these sightings along the south coast. I mean, also a little bit there near Dingle and so on. And then, of course, offshore. Right, that's good. But then I started looking, if you see the black triangles, they're actually not that close to the coast, because normally you don't really want a seismic station close to the coast. At the coast, it's very windy, and then everything shakes, and you just record that. So normally you step back a little bit from the coast. Well, there's the station here in Valencia. It's a very long-running station, you know, which was put in by the Americans in the 60s, and we're operating station there. That's the first one I had a look at. But I think the distance to these sightings there, okay, there's sightings, you know, the whales might, of course, also be closer than where people have seen them. You know, you don't see them all the time or at night and so on. So I couldn't find anything. But actually, over the years, over the last 20 years or even longer, many, many other stations had been deployed, not as part of the national network, but for various projects. And actually, I didn't really have the time to get all the locations of all these projects. I just have a subsample of it on that map. It's just to show you that, okay, there were a lot of stations. There were many more even, and some even from the time I was still in UCD with Chris Bean, the head of geophysics here, and moved with his research group here about nearly 10 years ago. So there's a lot of data. So then I looked, okay, what stations are really close to the south coast? And then to make it a bit shorter here, these are the stations I showed it earlier that actually then detected some whale calls. So I checked in the database when were there sightings. Turns out here, especially in Cork, it's usually especially in November. And this station, IP07, was up for 2 years, 2012 and 2013. And those three near Gully Head, they were a year later. And then the other station up there we installed actually last year. So I think I have to skip a few things here. I have a few more technical slides. I'll just quickly go through them to give you a flavor. I won't actually explain a lot. So these three stations that you can see in the map there. So I found an example where they picked up the same whale call at the same time, like you can see the seismograms here. And the amplitude, if you can look, if you can see the amplitude values here, for the station that's furthest inland, as you would expect, the amplitude is weaker because the signal gets weakened to have to travel all that way. So I was like, well, maybe this information can be used to locate where the call comes from. And it turns out, yes, you can. So just looking at these amplitudes, you can guess that the whale must have been somewhere there southeast of the coast, you know. By just creating a grid and doing some calculations, that's the only equation I will show. I think I don't have the time. It's quite simple, but you have the observed amplitudes, build the ratio, and then you calculate theoretical ones. You do this all along a grid, and you can figure out what was the most likely position where this sound came from, and this is the result. So the most likely area is then here where actually the whale appears as a sketch. Right, okay, that's nice. How reliable is that information? Well, in geophysics, we're always, you know, to give an error on something like this is nearly impossible. It's very, very difficult. So one thing we often do is, well, let's have another measurement method. So, you know, often we can't really say what's the exact error. But if you apply then 2 or 3 different methods and they agree, well, then that's good. So actually, that's possible in this case because at each side, the seismometer actually measures the movement in 3 directions. And if the whale call comes from that area, for example, and goes to that station UGAL 2, well, there should be more movement in the seismic ground vibration towards, well, in this case, north-northeast. And that's what you can see in the plot there to the right. But I will just skip over that. The result is that you can kind of point back to where it probably comes from. And then, fortunately, I got quite good agreement there in this case. I have another example. I have to skip through it because I don't have time. This is that you possibly can actually track how a whale is moving, even so you might not be sure whether it's a whale moving or maybe it's another whale that gives a signal close by. Right. So who cares? What's so interesting about this? You know, I mean, for us seismologists, it's just amazing. You know, we sometimes see vibrations coming from a volcano or from groundwater flow or something, and that's, to me at least, it's quite interesting. But this is an animal. That's quite different, really, than anything we have seen so far. But maybe it's of some use. You know, it turns out I started to read about fin whales and whales in general. It's not that much known actually about them. It's difficult because they're out. The ocean is huge, very difficult to study. The main way to study them is to, when you see them, well, that's only sometimes when they're at the surface and they have to be near a boat or near the coast. The other way is to use hydrophones. And there are, of course, hydrophones out in the ocean, but not that many, and also not often that they transmit the data. It's very difficult to transmit data through seawater. You know, it's very difficult. So maybe on land, we already have seismic stations that transmit data and they record all the time. So, and if the information is in there, well, that could be useful maybe and actually kind of free. That's kind of the idea. And yeah, so there are a lot of questions. So even the number of fin whales, where do they move at what time of the year? Are there different populations? Are there families? Are there big groups in different regions? Even how the sound, this really strong sound is produced and how the whales can actually hear it is not well understood. It's very hard to study because when you have a beached whale and you can study it, but it's so big, you know, so do an MRT scan of a whale brain or organ, it's all very, very complicated and difficult. And then also actually the couple of threats, you know, crossbars, you know, ship strikes are a problem, entanglement in fishing gear, noise pollution from all the boats going around, and there are more and more boats because we have more and more people and moving more and more stuff around the ocean, and climate change could be a thing as well. So number of fin whales, yeah, they're estimates like in this figure. And as you can see in this graph, from 1920 to 2010, so it's not really up to the present time, but you can see this massive decline like in the 40s, 60s, I mean, they were nearly gone, especially in the southern hemisphere, obviously, because they were hunted, you know, and nearly to extinction. And but fortunately, because of a moratorium that was called later on, I think it was in 1990 or a bit earlier, the numbers slowly keep increasing again. And in 2018, the status was changed from endangered to vulnerable for fin whales. But you know, what's the future? We have maybe to monitor this in detail really and make sure that these animals survive. They're the largest animal on the planet after the blue whale, so they're the two largest, and they're at the top of a big food chain, and surely they're important. So another graph I want to show you, I mean, this whale hunting and all this, it's pretty shocking actually when you look at the details. So yeah, this graph shows for different whale types, how many, again, estimated, what was the catching rate, how many were caught and killed, mainly in the early days, at least for the bladder. So they have a really thick fat layer around them to insulate them. But also they can travel really long distances without eating anything for months and just live off their bladder, you know, and humans hunted them for it and used this for, you know, to have a candle on your boat or in your house. And so you can see that in the graph, you can see that the blue whales were, you know, in the 30s, 40s, you know, before the World War, was mainly blue whales hunted. I mean, they're big animals. Once you get one, you get, you know, a lot of meat and a lot of bladder, but then it declined basically because there weren't many left, unfortunately, sadly. And then they said, well, what's next? Okay, then they went for fin whales. The reason the fin whales, the dashed lines, weren't hunted earlier was actually because they're the faster, I think, and there were more fin whales than blue whales. The fin whales are so fast. So back in around 1900, I mean, people weren't able to hunt them. They were just too fast. They were just swimming away. So before the graph here, they were mainly hunting right whales. And some people say and explain they're called right whales because they were the right whales to be hunted because they're big, but they're slow and they were easy. And then they were nearly gone. It's shocking. So when the fin whale numbers went down, this graph is for Antarctica. So if you remember the figure before, they were nearly all gone. So then sei whales and then minke whales. And actually, these are whale types that are much smaller. And then the moratorium kicked in. So talking about these different whale types, maybe just quickly. So whales of the world. On the left, all the whales facing to your right, they're baleen whales. And all the whales on the right, they're toothed whales. So that's a big difference. So the big whales, we are talking, the fin whale is the second one from the top here. On the top, you have the blue whale. On the left, the fin whale. And then I think you have the sei whale. And here, that's a minke there over this diver here, just for scale. And here on top, the largest toothed whale there, that's a sperm whale. And then this, of course, everyone knows it's orca whale. In the middle here, I should mention humpback whale, which you actually observe here in Ireland, also coming close to the coast. And then all these all the dolphins, smaller ones. And I learned, and I didn't know, that actually dolphins are whales, technically speaking, but all whales that are smaller than 3 or 4 meters, we don't call them whales, and we call them dolphins. For example, the orca is the largest dolphin, I learned. But we call it whale because, yeah, it's large. So what's the difference between baleen? What's this baleen? You know, so toothed whales, well, they have teeth. So the baleen, that's kind of, instead of teeth, they have this kind of brushy stuff. You can see in the image there on the bottom. And the interesting thing is the baleen whales, they eat krill. So they're the largest whales, but they eat much smaller things than the toothed whales. You know, they're not hunting and eating seals and all that. Not at all. They're eating krill and small things, small fish, but in huge quantities. And the way they do it is by lunge feeding. So they just throw themselves, open up their mouth, and they can gulp down huge amounts. What does it say? The size of a school bus. Again, I have some drone footage here. So cool. That was recorded December last year by Instagram account Hey from SK at Helvig Head, which is in Waterford, which is close to the one station where we also saw again some Instagram music. But you can see how they're feeding. This is actually a humpback. You can see the white flippers, but these are fin whales. And there you can see it feeding. Yeah, this drone footage is really amazing. So the other thing not well known is about the seasonal movements and where are they? You know, so I told you earlier, they're often seen in November around the south coast, the fin whales. And like in spring and early summer, that nowhere in Irish waters you will see fin whales. So where are they? You know, where do they go? Where do they come from? Are they in winter on the equator? Where are they? Well, in this graph, you see the migration routes of humpback whales, which are relatively well understood. So they basically, like also other baleen whales, they feed mainly in winter further up north, and then no, it's the other way around, of course. You know, in the summer they go up, and then in winter they're further south for breeding and just relaxing, I guess. But they're mainly feeding up north more than further down to the south off the coast of Africa and so on. So that's actually well established. And first people thought, it's probably similar for fin whales. Why should they be any different? You know. So as you can see here, so they have observed in the dark blue areas. Okay, I actually don't have my pointer on here. I can put that back on for the online people. But there's no one online actually, but we're recording it so that people can see it later. So the dark blue areas are known to be feeding grounds. So people thought, okay, and then they probably go down there. And sometimes you saw whales passing by island, they're going south. But actually, it turns out it's not that simple. So in this study here, the graph to the right, they tagged 25 whales. Very difficult to tag whales, and they tagged them from a helicopter. This is quite recent. And the tags don't stay really well on fin whales because they're swimming so fast. So the tags, they only stayed attached between 1 and 3 months in this study. They tagged 25 whales, and 10 of them just, they tagged them up there in Svalbard, north of Norway. 10 of them just stayed up there. And there's another study that anyway showed that all year round, on a hydrophone, you can see fin whales there. So clearly, they're not all migrating south. Some of them, as you can see, so 15 started moving, and only 2 really went relatively far down. You can see they're GPS tracks, so it's amazing nowadays. You can do these things, and black means the whale wasn't transitioned. Red is where they were feeding, and quite often they feed in areas where you have large gradient bathymetry, so where the water suddenly gets deeper, because there you get upwelling water, and there's some more fish and more food. And that probably explains why they come to the south coast, I believe, because of the Gulf Stream, you get upwelling, that's my assumption anyway, on the south coast. What's about population differentiation? So I have to show you this stuff about the humpbacks. You might actually know about this probably. So the humpbacks have much more complicated song patterns than the fin whales. They're really, really singing. And in the 70s, this was made very popular by Roger Payne, as he's called. So he got access to the data from the US military that still have, presumably, hydrophones all over the North Atlantic on the seafloor to monitor submarines, of course. And he got access to this data. And he saw this graph that I just showed, that there are not many fin whales left. If we continue hunting these whales, they'll be gone, and other whale types as well. This is disaster. He was working on bird sound before, and then he saw this and something has to happen, And then he discovered that humpback whales make these really amazing, I play it now, songs. And he said, well, when people listen to that, they'll be like, okay, there's some intelligence going on in these animals. We can't ignore it. You have to do something. Oh, no, I have to, of course, change my pointer. So very strange sounds, I can't play this long, I have to move on. Sorry about that, but very complex patterns. And it was discovered that for example, in this study, different populations have completely different songs, and the songs are really complicated. They go on for hours, and they repeat the song exactly in the same pattern. And then another population nearby has quite different songs. And then sometimes the songs change in the next season. So how can that be? And it was discovered that, for example, you can see along these populations from Australia to the French Polynesia. So each color in that graph marks a different song, and that actually the songs were passed on from one population to the other. And then the study has proven that it was not populations that migrate. So basically within a year, all the whales of a population in Tonga learned this other song that somehow came over from the neighboring islands. So, I mean, it's not like genetically, or, these whales get like 80, 90 years old, and then within 1 year, the whole population, thousands of whales, all sing the same song, but it's a new one. Well, you need some intelligence to do that, and actually you need culture to do this. It depends, of course, how exactly you define culture, but, it's definitely not genetic that you learn in a whole population a new song within a season. I skipped this. This just shows how complicated these songs are. But now going back to the fin whales. The fin whales don't have these complicated songs. But still, is there something in the songs that I showed you earlier where we could distinguish populations maybe? Well, it turns out probably yes. So in this graph, you can see a study, results of a study over 5 or 6 years, was in North Atlantic here. And it shows you this internode interval, so between these 1 second songs like. So, and it was something like 80 seconds, and then suddenly in 2002, it changed. Or actually, in that year, there were songs with still that 18-second gaps, the ein and eyes, but also then 12, it dropped. And it was shown that this as well was not down to the movement of a population, but actually was culturally transmitted. It's amazing. So another thing is that complexity in Finwell songs can be doublets and triplets. So what I showed you before, so you have just these repeating songs, so that they're called singlets. But sometimes, like this is actually from the station I showed you earlier, the location in Waterford. And you see, okay, my pointer. You see sometimes these 2 notes, and then they call them a back note, so slightly lower, a backbeat, a slightly lower frequency here in the spectrogram. And then 3, and then the backbeat and 2. So quite a bit like, I don't know what it means. I think nobody knows at the moment, and it's tricky. But there is complexity in there for sure. I skipped this one. And this actually, it plays automatically. That's handy. I just wanted to show you this doublet triplet pattern. In this case, I play it back 5 times faster than is normal, and that's why each sound is not really a second long, but yeah. All right, so yeah, the station I just showed you the data from. This is from this one in Waterford. The special thing about this station is that it's actually a citizen science station. So it's not one of these professional instruments we use. They cost like 5, 10, 15,000 euro. It's very specialized equipment. No, it's actually one of these so-called Raspberry Shakes. Do I have my pointer on? Yeah. So they're quite small here. They're like 10 by 10 centimeters. They're basically a Raspberry Pi, which is a mini computer, which costs only 30, 40 euros. And then there is a quite good geophone or small seismometer attached to it. And the whole thing costs 500, 600 euros, which is still a lot of money, but it's, order of magnitude cheaper than a professional seismometer. And we are running here in Dias in collaboration with the Geological Survey and funding also from Research Ireland, formerly SFI, the project QuakeShake, where we try to get citizens and schools involved in obtaining these stations and operating them. So basically, you have to connect it to power, give it internet, which sometimes can be a little bit tricky. Once you've managed that, the data just streams into this actually global system. So we are not running the system, it's a global system. And the data streams to the internet, and then you can see what you record on a smartphone app or also in a web browser. And if that interests any of you possibly, or if you know someone who might, we're running a workshop on Thursday in Donegal. In Donegal, because as you can see actually on the map here behind me, the circles are earthquakes. So there's seismic activity in Ireland, especially in Donegal. Sometimes there are felt earthquakes there. And that's why we have this workshop there. And we'll distribute 20 of these Raspberry Shakes there. So you can scan that code later on. I will leave that open or ask any one of us here. I have to get a little bit quicker now, isn't it? We have, yep. So yeah, these open research questions. One thing I wanted to mention are the threats to whales, not only fin whales, but actually I read that especially fin whales are endangered by ship strikes quite often. Unfortunately, the fin whales found that were injured. Entanglement in fishing gear, noise pollution, climate change. This is, I just picked this from the website marinetraffic.com. It's like flight radar, but for boats. And this is just the traffic from 2023. It looks very dramatic with all this red and so on, but there is quite a lot of activity, especially near the coast. So maybe the observation that you can use land seismometers to track or detect whales can help to, oh, there are whales at this time. Maybe then this is information that could be used to help protect them. So what's the current situation? So this map I showed you earlier, it's actually for data until 2023. So in this year so far, since 1st of June, so between February and June, there are no fin whales near the Irish coast, at least not the last 20 years. So since then, there were sightings at all these locations where we have red circles, and this is unprecedented. There are many, many sightings in Donegal Bay. You know, if you look on the left on the map, it's probably too small to see, but believe me, there are only 3 or 4 sightings in the last 18 years. And now this year, there were like already 20 or 30 sightings in Donegal Bay. Not sure why that is. Could it be because they don't like the South Coast anymore? There's too much noise, or is it because of climate change? I think at the moment, nobody knows. Maybe we can contribute. They're near the coast. Maybe this could be detected if you have stations there near the coast. And by the way, there was the first sighting here on the northern coast of Ulster, near Rathlin Island recently. Yeah, I don't have these sightings marked by months or something. So, but in this one, you can see just the last month and actually last week, there were a couple of sightings of fin whales in Donegal Bay. Right. So what's next? What are we doing? So these stations in County Cork, they operated 10 years ago. The Raspberry Shake there, as part of QuakeShake, is still operating now. We installed it a bit less than a year ago. We did go back to the Baltimore station and put one in there a year ago, and it did detect twice some fin whale calls. These circles are all fin whale sightings, but actually over the last 18 years. But in last year, there were only twice that we could see something in the data. And we went down and installed more stations. You can see all these colored triangles. But we did it in December, and at the time, there weren't any nearby fin whale sightings or calls in our data. And in Waterford, we actually installed a streaming station in the Balmahan Coast Guard station. The reason being, it's quite close to this Raspberry Shake, which, by the way, operates in the Copper Coast Geopark exhibition there in the church. So why did we put this other station nearby? Well, this has a professional grade seismometer, which we can sample at a higher rate. And I hope that maybe we can pick up humpback signals there, because sometimes they're seen here. So I'm nearly finished. There's one more slide, and you're free. So, of course, the idea is then, okay, this is all, you know, what we see in Ireland, but presumably this also happens in other places. So I did have a quick look around. I mean, there are tens of thousands of seismometers around the world. You know, you can't look through all the data, but I did look a little bit, read a few papers where fin whales seen near the coast, and then picked up some seismic data. And I could find whale sightings here in Iceland, in the Mediterranean. I didn't know beforehand there are fin whales in the Mediterranean. There are no blue whales, but there are fin whales in the Mediterranean. At a station right next to the Oceanographic Institute Museum, here's a plot, in Antarctica, next to this Argentine research base. And I also found some really strong signals actually at the Pacific coast of Mexico there. So I think that there could be many more information in the existing data worldwide, or even also in our own data. Maybe one has just to look closer at it. So I leave it at that. I want to thank everyone, first of all, for you coming here, and then for everyone who helped technically and setting up the room, and also the technical help I got, and from everyone who had any contribution to this. Thank you so much for your time and coming down here. And if you're interested into this QuakeShake project, you can later stand up and you can come to the screen and scan that QR code, or ask any one of us. Or also, if you can ask some questions now, of course. And then also in the entrance hall, there's some posters. If you want to have a look, you know, about some of our research, there is actually a Raspberry Shake on the monitor. Well, not on the monitor, it's on the ground, but the data of it is displayed on the monitor. If you want to talk to us, a couple of my colleagues are here. And there's also 2 monitors where you can see some of the earthquake detections of the INSN, of the national network. Thank you. Yes, anyone, any question?
QuakeShake founded. How long ago was it founded?
How long?
Ago was it founded? When
Oh, QuakeShake was founded, we started a bit more than a year. It's 1.5 years. Yeah, so we used to operate the Seismology in School project. That's before my time. I came here 8 or 9 years ago. And I lower the sound maybe a little bit.
Did you get funding from iCrag?
No, we got the funding from the Geological Survey. So it's part from the Geological Survey and DIAS, the national network, by the way, as well. I didn't mention that maybe. And then starting this year, we got 1 year extra funding from Research Ireland, formerly SFI, to buy 65, I think, of those stations to distribute them, because it turned out we couldn't really motivate people to buy them units themselves. So we thought, okay, if we hand them out, maybe that gives critical mass that people get more interested into it. And it starts to, yeah, we get quite a lot of feedback and people getting interested. If you're interested, just go to quakeshake.ie, and there you can subscribe to newsletter. There's an email address, you can contact us.
Are you finding any other noises kind of around the same frequency that are affecting where the whales might go or anything like that? Or is there any evidence of them avoiding anything?
That's very difficult to say for me. I mean, this is kind of a pilot study, so we would have to look at things in a lot more detail. But you can already see from the sightings, when you remember the map, all the sightings along the south coast, and then where we have Cork, there was a gap, and I assume there's so much boat traffic that they avoid that area and they're less often seen there. They probably just swim through and go to the quieter places. Yeah, but quite often you see other things. Yeah, you do. So sometimes there's no chance to see these fin whale calls, often also just by wind and stormy weather, actually. But you often also see during the day, when there's human activity, because the seismometers are on land, and then from car traffic or, some other noise, yeah, that you can't see it. Yeah. Yeah.
Is it known what distance the different types of whales, their sound can carry in the water and on land?
Yes. Yeah, on land, I know, because we tried it out. So the furthest we could see it inland is 4 kilometers, and I think the whale then has to be quite close. So I think overall we can detect it with land stations, maybe 5, maximum 6 kilometers. In the water, yeah, I was interested to know this as well, and people disagree, but easily tens of kilometers. And actually, I didn't really mention this. These are long distance calls. They're intentionally so low frequency, and they use it to communicate over long distances. And there are studies that have shown that only male whales are doing this. So it seems that they're mainly mating calls, but they could also be calls giving information about where's the food, and that might be coupled, obviously. And there are also just some people who say maybe they also use kind of the echo they get, because they look at features, bathymetry, where you get a change, where you get upwelling water. So maybe they use it that way as well. So, but how far, some people, when you just Google and say, oh, thousands of kilometers and so on. But then, because in the North Atlantic, there's an estimate there about 50,000 fin whales. So if they can hear it that far away, I mean, then how do you know who's saying what? And I think the tens of kilometers is probably a more accurate estimate. Yeah, that's what you read more often. Oh, sorry. Yeah.
The size of data is real time. So would the idea being maybe that we could work with marine scientists to get, if you got the data in real time, you could then send up a drone or something and get visual copy?
Absolutely, yeah. So the idea really is, as I said, we are physicists, geophysicists, so would be now to, and we are in contact with the Irish Whale and Dolphin Group. And the next step would be to pass this on really in a way. But then, yeah, if you would have more stations around the coast, and then one could automatically look for these kind of signals and then have a flag, a little bit like you detect earthquakes, you detect fin whale calls. Hey, there are fin whales here, And then, yeah, maybe because they might be there and you don't see them, if they don't surface or they do it at night and nobody's there, and then they're gone again the next day maybe, but they were there. So, but we maybe can still see them, actually, especially at night, because then our data is better normally. Yeah. So yeah, hopefully. All right. Okay, thanks.